Hi everyone, I am Aruna Aruchami, Assistant Professor, Department of Information Technology, SNS College of Technology. Today we are going to see about the cache memories in computer architecture. Cache memory is nothing but act as a buffer between your processor and this RAM, that is a random access memory. So mainly this can be used with a high speed memory, and also we can call it as a special memory. And also this may be used for the speed up and synchronizing your processor speed. And also the cost of this cache memory is higher than the main memory. And also what the data can be stored under the cache memory is the frequently used data or requested data or instruction holds in the cache memory. So by using the cache memory in the processor, it will reduce the average accessing time from the data from the main memory. And also what is the size of your cache memory means it is a smaller, and also the speed of the cache memory is a faster. It can occupies or it can store the data and instruction which is frequently requested in the memory location. And also in our processor we are having a different levels of cache. Each level can act as a independently which stores the instruction and data. So this is a sample example how the cache memory is present in our processor. So it will be present intermediate between our processor and the main memory. So this is the communication established between this is the way the communication established between the processor and the main memory. So this is also a cache memory. Think how the data or an instruction can be transferred. So here from processor to the cache memory, the word can be transferred. From cache memory to main memory, the block of data and instruction can be transferred, but speed of the thing is very slow when compared to the cache memory. The next one is between the secondary storage, a page can be transferred. Here the buffer can be acted as a virtual memory. Here the buffer can be acted as a cache memory. And also when compared to this thing, this is very much slower in the page transfer. There are different levels of caches in our processor. The level one memory is the register. Register is present inside your processor, so it is very much faster. The example for register is the accumulator, program counter, and address register. The second level of the memory is a cache memory. We well known that cache memory can be used to frequently used data, and also it is a very fastest memory, and the cost also higher than the main memory. And also it is a temporary storage. It is not a permanent storage. The third level of memory is a main memory. So it is a main memory. Nowadays we are working as a currently used memory. We can call it as a main memory. The size is a small in size, but when the power is of a longer stay in this memory. Once the power is off, data will be does not stored in the memory. Second thing is a secondary memory. This is a last hierarchy in the memory hierarchy. It is an external memory, but it will take time. The speed of the data processing is very slow. So these are the various levels of the memory. So the next thing we're going to discuss about the cache performance. Cache performance can be deal with the single level cache and the three level cache. What I have shown it over here is a single level cache. So the speed between the CPU and cache memory is a faster. Here in terms of word only, a data or an instruction can be transferred between the processor and the cache memory. The second thing is that between the cache memory and the main memory, a block of data can be transmitted. When compared to previous one, this is very slow. So this is a three level cache. This is a level 1, level 2 and level 3. Level 1 is fastest. Level 2 is a faster. Level 3 is a fast. Level 1 cache is must present inside a processor. Level 2 cache is either inside nor outside. Level 3 cache is outside the processor. So the cache performance can be calculated by two parameters. One is a cache hit, another one is a cache miss. The cache hit is nothing but if the processor requested data and instruction is present in the memory location in the cache, we can call it as a cache hit. So that can be read the data from the cache means we can say it is a cache hit. The processor does not find that the memory location in the cache means we can call it as a cache miss. So your processor can allocate the new location in the cache to fulfill the content of the requested data in the cache. So these are the two parameters can be used to calculate the performance of the cache memory. So this is a sample example I quoted over here, how it can be worked in our particular processor. So your cache memory can be measured in quantitative manner. We can call it as a hit ratio. Hit ratio is nothing but total number of hits divided by the total number of accessing time. So how we can improve the cache performance means by using the four ways. One is while increasing the cache block size. Another one is while reducing the miss rate and miss penalty. And as well as while reducing the time to hit in the cache, we can able to improve our cache performance. This is a simple notation how we can derive the cache hit and the cache miss. In the first attempt itself, a processor can identify data and instruction present in the cache memory. We can call it as a cache hit. If not available, the processor have to check the data in the main memory. Data is not available in the cache memory. Then we can call it as the cache miss. So your cache performance, another thing we can able to map the data between the processor and the main memory to the cache memory. How it can be taken place means by using the three mapping technique: direct mapping, fully associative mapping, K-way set associative mapping. In your direct mapping, so directly the block of data from main memory, it will be mapped to the cache memory with the help of this particular formula. I equal to J modulo M. Here I is nothing but number of lines present in the cache, and J is nothing but main memory block number. M or N, that is nothing but the number of lines in the cache memory. So based on this formula, we can able to map the particular main memory content in the cache memory. Here we are going to perform the mathematical operation that is called the modulus. Modulus is nothing but we are going to calculate the remainder of that thing. For example, if it is a 3 model 10, so the remainder is 3. So the particular requested block can be mapped to the cache line of 3. So this is the way a direct mapping can be works. And also here we doesn't have any replacement algorithm, does not need any replacement algorithm, because while whatever the data present in the main memory, it will be directly mapped in the cache memory. And also here a main memory block can map only to a particular line of the cache. New incoming block will always replace the existing block in the particular line itself, because it is a formula. If anything other than the same thing, we can easily replace the thing from the existing one. So this will be happen in the direct mapping. The next one is associative mapping. Associative mapping is nothing but to store the content address of the memory word between the main memory and the cache memory. Here in our cache memory, which one is freely available at that particular moment, a main memory content can be moved. We doesn't have any formula, we doesn't use any procedure. Whichever the line is free, we can map that particular data in over that. Here definitely we need the replacement algorithm, because which line is free, we can use it again. So if new request is entered, we doesn't have a space in the cache memory, definitely one have to remove, and the new one have to be entered in the cache memory. For that thing, we are using the replacement algorithm. So for example, FCFS, that is first come first serve algorithm, or least recently used algorithm. These are the major algorithm we are using under the associative mapping. By using the way, we are going to replace our older content with the newer content. The next thing is a set associative mapping. Here, the combination of direct mapping as well as a fully associative mapping can be used under this particular mapping. Here we are having a K-way set, either 2-way or 3-way or 4-way. And also we can set as a K can be any number. Here, block of main memory can map to only one particular set of cache. Within that set, the memory block can map any cache line it is freely available. So only we can call it as a combination of direct mapping and the fully associative mapping. The next thing is if k equal to 2, cache line contains 6 lines. So number of sets equal to 6 divided by 2. So we need the 3 cache line in the each set. This is the way we are calculating the how many number of lines to be present in the each set. Here definitely we require the replacement algorithm to change the older one with the newer one. So the next one is the types of cache. There are two types of caches available: primary cache, secondary cache. Primary cache is nothing but it is located on the processor chip itself. It is very small and its accessing time is comparatively to that of a processor register. Your secondary cache that is placed between the primary cache and the rest of the memory. It is referred to as a level 2 cache. Often level 2 cache is housed on the processor chip, either in a processor chip nor in the outside the processor. So these are the differentiate between the L1 cache, L2 cache and the L3 cache. So the major thing is how we can able to reference the locality of the particular data or an instruction. So this can be done by using two type of a locality. One is a temporal locality, another one is a spatial locality. Spatial locality is nothing but the item which nearby address tend to be referenced closely together in time. We can call it as a spatial locality. Your temporal locality can be called it as a recently referenced item or likely to be referenced again to the nearest future. This is the way a locality of information or locality of reference can be identified in the data or an instruction. Okay, these are the major topic to be covered under cache memories in the computer architecture. Thank you.